Lesson 4, logarithmic functions with base 10. So a logarithmic function has a log in it, and lots of the time it'll say log with a little 10. That's lowercase below the log. But also, if it says nothing, it just says log x, we assume that that is log base 10. So, for log base 10 of x, we're going to type in log, and on your calculator you just type log of -1. And you should get some sort of error message. You can't take a log in base 10 of an undefined number, or of a negative number, so it is undefined. If you do log of 0, you also get undefined. If you do log of 0.5, you should get negative 0.30103. So what I want you to do is pause the video and fill in this whole chart for log base 10 of x. So as you're filling them in, things that you should notice is that when you get to 1, you equal 0, so that is our x-intercept. And all of these numbers seem to be getting higher and higher. At 8, we're at 0.90309. At 9, we're at 0.95424. And at 10, we hit 1. So this is also an important number. We're going to start and come back to after we do the next example. So for the next example, we have 2 times the log of x. So you're going to get undefined for both -1 and 0. For 0.5, you should get negative 0.60201. So what I want you to do is pause the video and fill in this chart. So for the next one, you should get the following numbers, and notice that as they get bigger towards 10, they approach 2. So this is an important number, and once again, the x-intercept is at 0. And now we're going to do the last example. So we have -3 times the log of 10 times x, log base 10 of x. So you should get undefined for -1, undefined for 0. You should get 0.90308 for the first one. So pause the video and fill in the rest of the numbers. So we have the following numbers. So notice that our x-intercept is again 0. And this time our last number is -3. So we're just going to sketch them, then we're going to talk about what is important. So for the first one, it starts off little, it goes through x is equal to 1, and then it goes up to the point of 10 and 1. So it hugs the x-axis and then goes towards that point. So that's our logarithm. This one is an increasing logarithm because it gets bigger. For the next one, we're starting off small, going through the point x and 1, and at 10 and 2 we have a point. So it goes close to the x-axis. That looks really bad. But it should go close to the x-axis, through 1, and then through the point 10 and 2. And this one also increases. And the last one starts up and it's going to hug this x-axis. It's going to go through the point 1, and then down here it's going to go through negative 3. So that's what this logarithm would look like. So the important information is that if your a value, so this is a log 10 of x, if your a value is greater than 0, so if it's a positive number, it increases. If a is less than 0, it decreases. Also a really important point is this 10 point. So your graphs will go through the point when x is 10, y will be a, whatever your a value is, for logarithms in base 10. So here's your chart for logarithmic functions. This would be an increasing, and this would be a decreasing. And don't forget that when you have it in base 10, you'll have a point at 10, comma, a. It will go through that point because log base 10 of 10 is 1. That's why you'll have that point. So we want to predict the x-intercept, the number of y-intercepts, and behavior domain range for the function y equals negative 5 log of x. That is just supposed to be log of x like this. So we know that a is equal to negative 5. So because it's negative 5, this is a decreasing function, which means it will go down. So it will start, the end behavior means it will start in quadrant 1, and it's going to move down to quadrant 4. Our x-intercept is always going to be x equals 1. Our y-intercept is none. It will never cross the y-axis. Domain, because it has to be to the right of the x-axis, our domain is x such that x is greater than 0 for the real numbers, and our range can be anything. It'll go up and down forever. So this is kind of like the backwards of an exponential function. It's because it's the inverse. So we're going to graph this function, and the things that we need to remember to graph is that the x-intercept is a point at 1, 0, and also it will go through the point 10 and a, which is 10 and negative 5. So down here at negative 5 and 10 is a point. At x equals 1 is a point, which means that it's a decreasing function, so it'll start infinitely high. It'll go on and on to infinity up at the top. So you would hug the x-axis, go through x equals 1, and then down to negative 5. So that would be what your logarithmic function looks like. More like that. Oh, I erased it. So that's how you graph logarithms. I'm making it worse.